In section 7.4, we will look at similarity in right triangles. Our first theorem says the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and each other. So when we draw the altitude, we now have three triangles. First triangle, triangle ACB, is the entire large triangle. So we have one large triangle. Its right angle is up at angle C. We then have triangle ADC, so we have a small triangle on the right, and its right angle is at angle D. It's angle ADC. And then we have a medium-sized triangle, triangle CDB, where its right angle is at D, angle CDB. The geometric mean for two positive numbers a and b says that a is to x as x is to b. So in number 1, we want to find the geometric mean of 3 and 12. So 3 is my a, 12 is my b. We will set up a proportion to find our mean. So we can say that 3 is to x as x is to 12. And then take the cross product. 3 times 12 is 36. X times x is x squared. So the square root of 36 equals x. And we can simplify that as x is equal to positive and negative 6. Okay, similar idea number 2. Find the geometric mean of 4 and 16. So if 4 is my a and 16 is my b, then we can say 4 is to x as x is to 16. 4 times 16, 64. And x times x is x squared. Then take the square root of both sides. So square root of 64 equals x. And we can simplify x as positive and negative 8. A few corollaries. A says the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segments of the hypotenuse. So when we're given the altitude to the hypotenuse of a right triangle, we can set up a proportion to solve for our missing sides. So with the given triangle below, we would be able to say that AD is to CD as CD is to DB. So notice we have a repeat here for our lengths of sides. And that's what we just saw when we solved our problems for the geometric mean. B says the altitude to the hypotenuse of a right triangle separates the hypotenuse so that the length of each leg of the triangle is the geometric mean of the length of the adjacent hypotenuse segment and the length of the hypotenuse. So what we're saying here, CD is our altitude. It's separating the hypotenuse of our large triangle. The hypotenuse in the large triangle would be AB, the entire base here. And it's separating it into AD and DB, which are part of our other two smaller triangles. So we could say that either AD is to AC, as AC is to AB. So again, we see that geometric mean here. Or we could also say that DB is to CB, as CB is to AB. So again, the geometric mean. So it just means we have a repeat of either a variable or a number on the diagonal of our proportion. Okay, we're going to refer to the figure to complete each proportion. And looking at our figure, notice we have three triangles. We have a small triangle on the right, a medium triangle on the left, and then the whole figure makes up our large triangle. Also note that each triangle has a right angle, and so therefore they each have a hypotenuse, a smaller leg, and a larger leg. So when we write our proportions, it does not matter what order we start in or which triangle we start with, just as long as both ratios go in the same order. So in number 3, we have W is to T. So if you notice, W is the hypotenuse of the medium triangle, and T is the shorter side. So then it says X is to, okay, well X is the hypotenuse of our smaller triangle, and then Y would be the shorter side of our smaller triangle. In number 4, Z is to T. So Z is the longer side in our medium triangle, T is the shorter side. As T is to Y. T is the longer side in our smaller triangle, Y is the shorter side. 5, T is to X as Z is to, so T shorter or longer side in our small triangle, X is the hypotenuse. Z is the longer side in our medium triangle, W is its hypotenuse. In 6, Z plus Y. So Z plus Y is the entire base of the triangle, which is the hypotenuse of our larger triangle. So we have hypotenuse over X is the shorter side, and then we have X, so that's the hypotenuse of the shorter, then this would have to be Y. So we have hypotenuse over short side, hypotenuse over short side. In 7, we have hypotenuse over short side for the small triangle, so then we need hypotenuse of the large one over short side of the large one. Let's see, in 8, W over X, so that's long side over short side for the big triangle, and that would be Z over T, long side over short side for the medium triangle. And in 9, Z over W, so that's long side over hypotenuse in the medium triangle. Then we have W is the long side of the big triangle, Z plus Y is the hypotenuse. Okay, in 10 and 11, we are going to solve for X and Y. So in number 10, let's first look to solve for X. So X is part of our small triangle from the left and our medium triangle on the right. So I'm going to start with a proportion, just putting X. So X is the long side in my small triangle. 3 is my shorter side in my small triangle. Then 6 is my longer side in the medium triangle. X is my shorter side. So notice my X's are diagonal to each other, so therefore I can take the cross product, and I actually am taking the geometric mean here. I get X squared equals 18. So that means that X is the square root of 18. Now, 18 is not a perfect square, but we can simplify that. Remember, that's the same as square root 9 times square root 2, or 3 root 2. And when we are finding lengths of triangles, we only take the positive answer. Okay, now if I want to find Y, we see that Y is part of our medium triangle, and it's also part of the large triangle. In the medium triangle, it is my hypotenuse. So if I put my hypotenuse over my longer side, then the hypotenuse of my large triangle is 3 plus 6. It's this entire base of my triangle over the longer side, which is Y. So again, we have a geometric mean here. Now taking the cross product, Y times Y is Y squared. 3 plus 6 is 9, and 6 times 9 is 54. So then Y equals the square root of 54. 54 is not a perfect square, but I can simplify that. We can break that down into 9 times 6, or 3 root 6. So now I just found x and y. Alright, let's look at number 11. Let's first solve for x. So x is part of the large triangle and the medium triangle. In the medium triangle, it is the longer side. So if I put the longer side over the short side, now the small triangle is the only other triangle where I know the long side and the short side. The long side of the small triangle is 6, the short side's 2. So even though I didn't end up with variables across from each other, I still have a geometric mean. I have 6 and 6 diagonal with one another. So let's go ahead and solve this proportion. We get 2x equals 36, so x is 18. You don't always end up multiplying two variables and then having to take the square root when you solve these types of problems. Alright, now let's solve for y. So again, y is part of our large triangle and our medium triangle. In the medium triangle is the hypotenuse, so if I put hypotenuse over the longer side, which we just found to be 18, so we're going to be using that x value now. And then the hypotenuse of the large triangle is 18 plus 2. It's the entire base. And its longer side is y. So now take the cross product. Y times y is y squared. And then I'm taking 18 times 20, or 360. So y equals the square root of 360, which is not a perfect square, but we can simplify this as 36 and 10. So y is equal to 6 root 10. These problems are a little trickier and will get easier, at least a little better, with some practice. In number 12, it says, at a golf course, Maria drove her ball 192 yards straight toward the cup. Her brother Gabe drove his ball 240 yards, but not toward the cup. The diagram shows the results. Find x and y, the remaining distances from the cup. Let's first solve for x, which would be Maria's distance to the cup. So x is part of our small triangle, and it's also part of the large triangle. In the large triangle, it makes up part of the hypotenuse. So I'm going to put x plus 192. That would be the entire hypotenuse of my large triangle. And we have to add those two together to get that whole hypotenuse. And then the larger side is 240. Now, in my medium triangle, I know the hypotenuse and larger side. The hypotenuse is 240. Larger side is 192. Then take the cross product. So we have 192 times x plus 192 equals 240 times 240, or 57,600. Then we distribute on the left. If I subtract to get x by itself, I have 192x equals 20,736. Divide by 192, so x is 108 yards. So Maria has 108 yards left to go. Alright, now let's find y, which is Gabe's distance to the cup. So we notice that y is part of the large triangle and our small triangle. And I'm also going to need to utilize x's value, which we found to be 108. So in the small triangle, it is the hypotenuse. So if I put hypotenuse over the shorter side, which we found to be 108, then I need the hypotenuse of my large triangle. So we have to add 108 plus 192, and we'll put that over the shorter side, which is y. 108 plus 192 gives me 300. Then take the cross product. Y times y is y squared. 108 times 300, 32,400. So y will be the square root of that, which it ends up being a perfect square of 180 yards. So the key in these types of problems is noticing what you're given for each triangle and setting up your ratios in the same order. So if you have hypotenuse over shorter side, your other ratio has to be hypotenuse over shorter side. Or if you have short side over long side, then your other ratio, short side over long side. All right, let's look at our last two examples in this section. Number 13 says the 300-meter path to the information center and the 400-meter path to the canoe rental dock meet at a right angle at the parking lot. Marla walks straight from the parking lot to the lake as shown, where a sign tells her she is 320 meters from the dock. How far is Marla from the information center? Okay, so most of our things are labeled in our diagram, except we have to mark that says she's 320 meters from the dock. Okay, so we want to first solve for x, because we want to know how far is she from the information center. So we notice x is part of our small triangle and the large triangle. And the large triangle is the hypotenuse, but I have to add it with the 320 to get the entire hypotenuse of the large triangle. So if I have hypotenuse over long side, then I need hypotenuse over long side. Well, I know the hypotenuse of my medium triangle and the long side is 320. Then take the cross product to solve. So we're taking 320 times x plus 320 equals 400 times 400, or 160,000. Then distribute on the left. Okay, kind of running out of room here. But then if we subtract, we have 320x equals 57,600. And then divide and get that x is 180 meters. Okay. And then I'm going to fill that in our diagram because we might need that for number 14. 14, we're asked how far did Marla walk from the parking lot to the lake. So that would be our altitude. So I'm solving for y now. Now y is part of our medium triangle and our small triangle. In my medium triangle, it's the shorter side. So if I have short side over long side, then I can have short side, which we just solved for was 180, over long side. And take the cross product. Y squared equals 57,600. So y is the square root of that, which actually is a perfect square. So y is 240 meters. So she walked 240 meters from the parking lot to the lake.